Alright, so let us try to see where the probability pops out from the picture. I'm just going to give you a spoiler. It is from our assumptions of how our objective function is like, right? We choose the objective function to be a mean square error. It turns out that the mean square error hides the probabilistic interpretation behind it, right? So what I'm going to do now is to show you where it comes out from. But before that, I have to introduce a concept that might be not you might not be very familiar with, right? And that is called the maximum likelihood estimate. Likelihood estimate, right? So if you have taken, say, 2131 and 2132, you will probably have seen it in 2132, right? But if you took the 2334 path, you might not have seen this before. So I'm going to give you like a short introduction to this idea. Okay, so suppose that your friend give you a coin, right? And this coin could be biased, could be unbiased, right? You know that is one of these three coins. You know that it is either a coin where the probability of it being hit is 0.2. It could be a coin where the probability that it being hit is 0.5. And it could be a coin where the probability that it being hit is 0.8. You don't know which coin it is though, right? But you get to play around with the coin. You get to do something with it. What would you do? So one thing that you might possibly try to do is to just flip the coin, right? Flip the coin a few times. Say you flip the coin 10 times and what you get out is hit, hit, tail, tail, hit, tail, 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 1, 2, 3, 4, 5, 6, 7, 8, 9, perhaps another tail, right? So we have 3 hits and 7 tails. So which coin do you think it is, right? If the P represents the probability that the coin is hit, it seems intuitively that it should be the first coin, right? The coin where P is equals to 0.2. But can we actually write this down mathematically, right? Justify this in a mathematical sense. Okay, so we're going to try to do this. Right, I'm going to call this particular coin C0.2. I'm going to call this coin C0.5 and this coin C0.8. So what I'm going to do now is to look at the probability that I see my outcome, right? Probability that I see my outcome, given that I assume that the coin is some particular coin, right? So for example, if I assume that my coin is in fact the C0.2 coin, what is the probability that I see this specific outcome? Well, the probability that I see this specific outcome will be 0. Well, what's the probability I see the hit? The 0.2, right? The probability that I see hit 3 times, that's 0.2 to the power of 3. And then the probability that I see tails for the rest is 0.8 to the power of 7. Okay? Now we can do the same thing for all the coins here. The probability that you see your outcome, given that we assume our coin is this, well, that is just 0.5 to the power 0.5 to the power of 3 times 0.5 to the power of 5, right? And the same thing, the probability that we see our outcome, given that the coin is the 0.8 coin, well, the probability that we see the first hit is actually 0.2. In fact, that would be what? Sorry, the probability that we see a hit is what? 0.8, right? So we have 0.8 times 0.8 times 0.2 and so on and so forth. So what we have is 0.8 to the power of 3 times 0.2 to the power of 7. And if you compare the quantity of this thing, clearly the ones where you assume the coin is 0.2 comes out to be the highest, right? This is the largest quantity here. Okay? So some terminology right here that you should know. This particular probability here is called a likelihood. What is the likelihood that you see this outcome given your assumption? Okay, so if you assume something, what is the likelihood of the outcome? And in this case, the likelihood of this outcome is the highest if you assume that the coin is the C0.2. And now you can see why the name is called maximum likelihood estimate, right? So the estimate here, the estimate of what coin it comes from, well, a good guess, according to this MLE derivation, is that it comes from this first coin right here, okay? So this is essentially maximum likelihood estimate.